Hi there. In the previous video, we had a look at working out the area between a function and the x-axis. And now we're just bumping it up one point here and saying, well, what happens if the function is given by here, and then we are given another function and we want to look at the area trapped in between. So, commonly said, find the area between two curves, even though this one here is a straight line, so it's not going to be a curve. But we start with the same way. We start by probably visualizing it is probably the best way to look at it first, which means doing a quick sketch of both of those functions so that we can get a sense of what it looks like and going from there. So let's start off with the first function there, which is the same as the last example, but I'll quickly get onto that. So if we let x equals 0, then y equals -5. So that's the y-intercept. Just doing a really quick solution here. And 0 equals -x squared plus 6x minus 5. 0 equals x squared minus 6x plus 5, which is equal to x minus 5, x minus 1. Therefore, x equals 5 and x equals 1. So we have, that's the y-intercept. We have 1, 0 and 5, 0 as our two x-intercepts. This is really quick graphing here. For number 2, we have a straight line here, y equals x plus 1. So we can see that when x equals 0, y is equal to 1. So we have the y-intercept 0, 1. And when we let y equal 0, we have 0 equals x plus 1. So x equals -1 for the x-intercept. Okay, so that's okay. If I now draw a really quick sketch, what we can see is that the parabola, which is equation 1, the quadratic, would be something along the lines of this, where that's 1, and that's 5, and that's -5. It's out of proportion, isn't it? But that's okay. And then we have this next function, which I might just draw in a different color. Draw it in blue. And this will be equation 2 is drawn in blue. We have when x equals 0, y equals 1. So it's going to be something like this. And when x equals when y equals 0, x equals -1. So it's going to be like this. And so the graph is going to be something like that. That's a really rough sketch. But what we can see is that the first equation is up here, and the second equation is here. And we're asked to find the area between the two curves, which I'll just shade in as red. So it's this bit here. Okay, now this is where it's going to get a little bit hairy, so just bear with me. What we clearly have is 2 points here and here, which will denote the start and the end of the areas I need to find. Now, if I just use sort of an orangey color to denote the area from this point here to this point here, and then say, well, the area underneath, I can use the integration to work out the area underneath the black curve, and that would be this. I'm going to shade it and then I'm going to get rid of it because it gets really messy. So it would be this. That would be that area. I can also work out the area under the blue curve. I'll do that in purple, and that would be this between the orange lines, like so. So if you have a think about it, if I take the integral of this bit and then subtract the integral of this bit, then I'll be left with just this bit, which is what we're looking for. Okay, so that's going to be our general approach. If you think about it, we've got 3 steps. We need to visualize, and we visualize so we know which curve goes on top of which one. We then need to find the intersection points, okay, because that'll give us basically A and B. And then we can use integration to solve our problem. So let's go through this really quickly. Okay, so this is visualization. So step 1, visualize. Just by quick and dirty graph drawing. Haven't worked out the turning point because it's not necessary for what I'm doing. I need to know roughly what the shape's supposed to be, and I've done that. And then the rest of it is as is. Number 2, I've got to work out those points of intersection. I can do that by setting equation 1 equal to equation 2. So that means that I'll have x plus 1, which is the value of y in equation 2, equaling negative x squared plus 6x minus 5, which is the first equation. So just setting them equal to each other, which is our standard way of working out a point of intersection. Now I'm just going to collect everything over to the right hand side. So I've got 0 is equal to negative x squared. I've taken x from both sides, so now I've got 5x left, and I've taken 1 from both sides, so I've got minus 6. So I've got 0 equals negative x squared plus 5x minus 6, and I need to work out the values of x there. So I'm going to do so. I'm going to divide through by negative 1 first, or multiply through by negative 1. Always handy when you've got 0 on one of the sides. That gets me x squared minus 5x plus 6. And I have to work out 2 values that will multiply together to give me 6 that will add together to give me negative 5. And I'll let you think about that yourself if you want to pause the video. But otherwise, I think I can go straight to it. Negative 3 multiplied by negative 2 will give me positive 6. And negative 3 plus negative 2 gives me negative 5. So that leaves me with x equals 3 or x equals 2. So these become my points of intersection. So let me go back to my visualization and just write that in underneath. So that will be 2 and 3. Okay, so that's really good. We've got our lower bound and our upper bound. So now I can proceed with step 3, and I can work out the integral of, oops, I'll just change colors. I now know the boundary is between 2 and 3, and I know that I need to subtract the integral of y2 from the integral of y1, where y1 is the first equation. So I've got negative x squared plus 6x minus 5. That's the first equation. And I'm going to subtract the equation underneath, which is x plus 1. And that's all with respect to x. So I'm going to simplify the inside. Now note, what I could have done, in a way I've kind of simplified a couple of steps here, is I could have said the integral between 2 and 3 of this minus the integral of x plus 1 with respect to x. But there is a rule that says if you've got the integral, if the start and end point is the same for one function minus the start and end point of a second function, then you can just subtract the functions. And it just makes it a little bit simpler in the end, but you don't have to, because it just means I've got a simplification step here. And that is, I've got negative x squared, and I've got 6x minus x, so I've got 5x, and minus 5 minus 1 is minus 6 with respect to x, which I'm now going to integrate. So I've got negative 1/3 x cubed plus 5 times a half x squared minus 6x with respect, and the boundaries are 2 and 3. So now I can substitute those values in and solve. which is just a bit of a numerical calculation thing to do. So I'll quickly get started on that. So we've got minus a third 3 cubed plus 5 over 2 multiplied by 3 squared minus 6 multiplied by 3 minus a third multiplied by 2 cubed, plus 5 over 2 multiplied by 2 squared minus 6 multiplied by 2. Okay, just keeping those brackets in there because when I'm subtracting stuff it can get a bit tricky. Okay, so I've got 3 cubed here, but I'm taking a third of it, so it's just going to be 3 squared really, so it's going to be negative 9. 3 squared is 9 times 5 is 45, so I've got plus 45 on 2 minus 18. And then the next bit here, it's going to be a bit careful. 2 cubed is 8, so I'm going to have minus 8 on 3. But I'm subtracting it, so it's going to become a plus 8 on 3. And this bit here, that 2 is going to cancel out a 2 here, so it's just going to be 5 2s are 10. I'm subtracting it, sorry. I nearly made this mistake myself, so I've got plus 10. Oops, sorry. I've got plus 10 here, but I'm subtracting it, so it becomes a minus 10. And then I've got minus 12, but I'm subtracting minus 12, and so it becomes plus 12 here. So it's a bit of fraction work from this point on, but at the end of the day, you're going to end up with a numerical answer here. So I'll let you pause the video for a moment and see whether you can get a final answer. Okay, so I've given you a chance to just have a crack at doing that numerical work. And I'll just on the next line just to get us started here. And all I've done is I've added up all the whole numbers to make it nice and easy. So I've got negative 25, and I've got 45 over 2, which is what, 22 and a half, and 8 over 3, which is 2 2/3. So we're going to be positive, but only just. And that sounds okay to me. But let's just have a look at exactly what it is. Let's just do the fraction work just for the sake of it. So the common denominator is going to be 6. So I'm going to take 25 and I'm going to multiply it by 6. And that'll give me minus 150. And then I'm going to have to multiply 45 by 3. And that will give me 135. And then I'm going to multiply 8 by 2. And that'll give me 16 all over 6. And that'll be, so we've got minus 150. And then we're going to add 135. And we're going to add 16. And then, oh my goodness, well, 135 plus 16 is 151. So we're going to end up with 1/6. The area is 1/6. Now, looking at that, it doesn't look too good, but doesn't look too crazy either, I think, because my scale is way screwed up here, I think, because, you know, there's a distance of 5 there and so on. So I kind of suspect that this sliver would be quite small. Remember that area is signed. It is positive or and negative when you're working out the integral. So negative if it's below the x-axis and positive if it's above. So I'm pleased to see that it's a positive area. If it's been a negative area, it doesn't mean that it's wrong. It just means that you'd expect it to be underneath the curve, but it's not. So that's good. So underneath the x-axis, sorry, and it's not, so that's good. 1/6 is pretty small, but I suspect the sliver is probably smaller than my rough graph shows. So overall, I'm pretty happy with that. I think it's okay. So visualize points of intersection, and then integrate are my 3 steps there. And, you know, step 4, which I've ended this video with really, is reasonableness, you know, looking at it and saying, oh, does that look about right? Does it, am I satisfied with that? And the answer is, yeah, I think I am satisfied. I've got a width of just 1 here. So a fraction of 1 as my area sounds pretty reasonable. So, you know, I'm happy with that. Now, obviously I'm over talking it now, but in an exam, you taking a moment in the exam and going, is my answer reasonable or not? Could be the difference between 3 marks and none, potentially. So it's always worth just taking a step back. Okay, I've already over talked it, so I won't talk anymore, but hopefully that gives you a good sense of how to solve these problems where you've got area between curves.